Good morning students. Today we are going to start with a new chapter, that is calorimetry, and in this chapter we are going to study basically about heat capacity, specific heat capacity and its measurement. So let us start with the common term which is used over here, that is heat. What is heat? As you people are aware that heat is a form of energy. But which type of energy we are talking about here? Basically we are talking about total internal energy present in the substance. Now what is the meaning of this total internal energy present in the substance? As we are aware that all the substances are made up of molecules, and these molecules are in random motion. So all the molecules, they possesses kinetic energy, as well as all the molecules, they are attracting each other, and there is intermolecular force of attraction between them. So all the molecules, they possess potential energy. So the sum of this total kinetic energy and potential energy possessed by all the molecules of the substance, that makes its total internal energy for a particular substance. So this total internal energy of a substance is known as heat energy of the substance, because heat energy is possessed because of these two things. One is the total random motion of the particles. Just because of that, the particles, they possess kinetic energy, and because of the molecular force of attraction, they possess potential energy. So in total, whatever energy we are getting, that we are saying as total internal energy, and that makes the heat energy present in the substance. So basically we need to talk about now SI units of heat energy. The SI unit of heat energy, as it is a form of energy, so that is the same which we are using for energy, that is joule. It is denoted by capital J. But one more unit we are supposed to study when we are talking about heat, that is calorie. What is this calorie? Basically this calorie is considered as practical unit for heat. Okay, and what is this calorie? 1 calorie is the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. Basically what can we say? 1 calorie is the amount of heat required to raise the temperature of water by 1 degrees Celsius, because in total the temperature of water is increased by 1 degree Celsius. Okay, why we are considering it from 14.5 to 15.5? Because you people are aware about the anomalous expansion of water, the anomalous behavior of water. So that's why we are taking this range of temperature. There the value will not differ. So basically 1 calorie, it is the amount of heat energy required to increase the temperature of 1 gram of water by 1 degree Celsius. And where are we studying this 1 degree Celsius? Basically we are studying it from 14.5 degrees Celsius to 15.5 degrees Celsius. This calorie is represented by CAL, and this SI unit and calorie, they are related to each other. How this SI unit and calorie related to each other? 1 joule is equal to 0.24 calories, or reverse can also be asked, that is 1 calorie is equal to 4.186 joule, or sometimes it is written as 4.2 joules. Both ways it will be correct. So these are the two relations which you people are supposed to remember, because these can also be asked for your 1 marks in your exam. That is 1 joule is equal to 0.24 calorie and 1 calorie is equal to 4.186 joule. Better to write this value. Okay, otherwise if you don't remember, you can write it this way also, but you can consider this first. Priority should be this one. Okay, now coming on to the next part of this chapter, the term which we need to discuss is temperature. What is temperature? Temperature basically is the parameter which tells the thermal state of a body. Thermal means heat. What is whether the body is hot or whether the body is cold. So that thermal state is given by a particular parameter. That parameter we are using here as temperature. So this temperature is the parameter which tells about the thermal state of the body, or you can say it tells about the degree of hotness or coldness of body. that is known as temperature. This temperature is measured in SI unit as kelvins. The SI unit for temperature is Kelvin. Other units which we are using to measure temperature is degree Celsius and degree Fahrenheit too. Kelvin is represented by capital K. Again the same thing when we are talking about temperature and different unit of these temperature. So we should know ki how SI unit is related to degree Celsius. This is the most common unit which we are using to measure temperature. Otherwise, when we are not talking about laboratory purpose and all that. So I hope you are aware that this Kelvin is a bigger unit and this Celsius is a smaller unit. So just to make you remember कि उसको याद कैसे रखना है, you can remember it this way. The temperature in Kelvin is equal to temperature in degree Celsius. How these two are related? Kelvin बड़ा है तो write capital T here. Degree Celsius is the smaller unit, then write small t over here. This is bigger unit. This cannot be equivalent to the smaller one. That means to make these two equal, we have to add something over here. And what we are supposed to add it? We are supposed to add 273 here. So this is the relation how this temperature in Kelvin is equal to temperature in degree Celsius. Temperature in Kelvin is equal to temperature in degree Celsius plus 273. This is another one of the question which can be asked in your paper, that how temperature in Kelvin and degree Celsius are related to each other. Okay. Now the next thing which we want to discuss is when we are talking about a substance and we are talking about it can absorb heat, and after absorbing heat it is going to raise its temperature. How much temperature is raised, how much heat is absorbed by the substance, what is the mass of the substance which we have taken, all these things we need to discuss. But we are discussing in one aspect only, that the amount of heat absorbed by the substance, it depends on how many factors. Okay, we'll understand it with the help of one example. Suppose this is 1 gram of water in a container. I'm saying suppose this is 10 gram. Instead of 1, I'm saying this is 10 gram of water. Okay. And in another container, I have taken some other amount of water. Say it is 50 grams. This is 50 gram of water. Okay. Initially, in both the containers, I have taken water at 20 degrees Celsius. In this also, I have taken it as at 20 degrees Celsius. Now I have to supply heat to raise the temperature of this water which is present in both the beakers. And when I will supply heat, definitely this will start absorbing the heat. After a particular time, it will start raising its temperature when it is able to absorb enough amount of heat which is required to raise its temperature. And after some time, it is able to raise its temperature from 20 to 21 degrees Celsius or to 40 degrees Celsius or to 100 degrees Celsius, whatever is the required scenario. Okay, now assume that I am supplying heat at constant rate or at similar rate to both the containers. जितना rate से मैंने heat A पर supply किया, उतना ही same rate से I am supplying heat to the B. Okay. Now as the mass in both the containers is different and I am supplying the heat at the same rate, in the same amount, then how can I raise the temperature of this 10 gram of water by 40 degrees Celsius and this 50 gram of water by 40 degrees Celsius? Definitely this rise in temperature will be achieved soon. ये जल्दी हो जाएगा because only 10 gram of water is there. Only 10 gram of water has to raise its temperature from 20 to 40 degree because the mass of water is less. But in case of this 50 gram of water, because I am supplying the heat at the same rate, it needs approximate 5 times time to raise its temperature from 20 to 40 degrees Celsius. Suppose this happens in 5 minutes. So this happens approximate in 25 minutes. Because the quantity is 5 times than that of this, and if I am applying same rate of heat to both the containers, that means the time will be multiplied. Definitely it will be. So from here what can I say? The heat absorbed, heat is denoted by generally Q, or you can write it this way, this heat absorbed to raise the temperature is depending on one of the factor, that is mass of the substance which I have taken. So heat absorbed or heat required, you can write here required also, the heat required to raise the temperature depends on mass of the substance. This is my first factor. Okay, now let's talk about the second factor in the same example. Suppose this water is at 10 degrees Celsius and this water is at 40 degrees Celsius. Okay, and the amount of water is same now. Here it is 40 grams and here also it is 40 grams. If the amount of water is same and I am supplying the heat at the same rate, then what will happen? Which one will be heated first? I have to achieve it 10 to 100 degrees Celsius. I have to bring this water to its boiling point, and this is also 100 degrees Celsius. This water initially is at 10 degrees Celsius. The amount is 40 gram. Means I have to heat 40 gram of water from 10 degree to 100 degrees Celsius. In this container, I have to heat 40 gram of water from 40 to 100 degrees Celsius. So it's quite obvious this one is achieved first. Isn't it? The amount is same, the rate to which I'm supplying the heat, that is also same, but the initial temperature of water in both the containers is different. That means the rise in temperature, or you can say the change in temperature, is different. Here the change in temperature will be 90 degree. हमें कितने का change चाहिए? 90 degree का. Here delta T, which is change, that is of 60 degree. So I believe 60 degree raised, the 60 degree rise in temperature, that can be achieved faster as compared to 90 degree rise in temperature. So this will be achieved first as compared to this. So what can I say? The heat required also depends on the temperature, not only on the temperature. You can say here the change in temperature, or you can write the initial and final temperature. So better to write, instead of writing initial and final, you can use one term, that is change in temperature. Okay. What is the third thing? Third is, when we are talking about a substance and we are talking about heat required to raise the temperature of the substance. So here, instead of water in both the containers, I can talk about, I am talking about a piece of iron and a piece of copper. Okay, or I am saying a piece of wood or a piece of iron. That I believe you can understand better. Iron is a good conductor. It is not able to absorb much amount of heat to raise its temperature. Quickly it will start raising its temperature. Whereas wood is an insulator. It keeps on absorbing the heat and it will hardly raise its temperature. This you can understand with the example with your, you can say, kitchen utensils. If you are using a pan which is not having any, you can say, that black handle. Okay, directly it is made up of that metal only. वो steel का बना है या aluminium का बना है. If you are cooking something in that pan and you are going to touch the handle, definitely it will be, it's very hot and you are going to hurt yourself. But if you are using pressure cooker and some other utensil which has a bakelite handle, जो वो black color का एक handle बना होता है, that is an insulator, and if you will touch it while cooking something, you are not going to hurt yourself because that time it is not hot, because that is insulator. So that keep on absorbing the heat without raising its temperature, whereas metals, they are not able to absorb much amount of heat. So that means this heat required to raise the temperature, that also depends on the substance. If substance is a good conductor, it absorbs less amount of heat and raises its temperature easily. When we are talking about insulators, insulators are not able to absorb much amount of heat without raising its temperature. So the third factor on which it depends, that is the material of substance. So that means heat required to raise the temperature, that depends on these three factors. One is the mass of substance. More will be the mass, more will be the heat required. Change in temperature, more will be the change in temperature, more will be the heat required to raise the temperature. And third is material of substance. If it is a conductor, less amount of heat is required to raise the temperature. If it is an insulator, more amount of heat is required to raise the temperature. Now coming on to next term which we need to study in this chapter is, that is heat capacity. Okay. Now as I told you just now, that all the substances, they require different amount of heat to raise their temperature. As we discussed just now, that conductors, they need less amount of heat to raise their temperature, and insulators, they need more amount of heat to raise their temperature. That means to raise the temperature to a specific value, all the substances, they need different amount of heat energy. So this measurement, how can we measure that how much amount of heat energy is required to raise this much amount of temperature? So that we are measuring in terms of heat capacity. capacity. Means indirectly, if I need to speak in general layman language, that how much any of the substance can have heat with it to raise its temperature. किसी भी एक substance को, suppose I am talking about wood, मैंने wood लिया and I'll start heating this piece of wood. Okay, कितना ये हीट एब्जॉर्ब कर सकता है, कितनी इसकी कैपेसिटी है टू एब्जॉर्ब द हीट, दैट इज नोन एज हीट कैपेसिटी ऑफ द वुड. बट द क्वेश्चन इज कब तक उसको हीट एब्जॉर्ब करनी है, कितना टेम्परेचर राइज करना है, दैट वी नीड टू टेक केयर. सो हियर वी आर स्पेसिफाइंग वन थिंग, दैट इज टू रेज द टेम्परेचर of itself by 1 degree Celsius. It is initially at whatever temperature. Suppose it is at 20 degree Celsius. Okay, it has to increase its temperature till 1 degree Celsius. That means it has to be at 21 degree Celsius. So what will be the change in temperature? That is 1 degree Celsius. Means to raise its temperature by 1 degree Celsius, whatever is the amount of heat absorbed by the wood is known as heat capacity of the wood. Okay, similar way, if I'm talking about any other substance, if I'm talking about milk, if I'm talking about copper, if I'm talking about aluminium, suppose I'm talking about copper. Okay, I'm not talking about the amount of copper. Whatever is the initial temperature of the copper, suppose it is 40 degrees Celsius, it has to increase its temperature by 1 degree Celsius. That means delta T is equal to 1 degree Celsius. Delta is for small change. So what will be the change from 40 to 41? So the change is 1 degree Celsius. So to raise its temperature by 1 degree Celsius, copper is going to absorb the heat. The amount of heat which is absorbed by the copper to raise its temperature by 1 degree Celsius is the heat capacity of copper. So I hope we can define heat capacity from here. How can we define it? Heat capacity is the amount of heat required. It is the amount of heat required to raise the temperature required by what? By substance or any body to raise its temperature by 1 degree Celsius. By 1 degrees Celsius. Now how can we write down the formula for this? Suppose delta T will be the change in the temperature, and for that the heat required is Q. Okay, Q is representing your heat required. Suppose delta T is the change in temperature and heat required is Q. This delta T can be 4 degree, can be 5 degree, can be 6 degree. Initially maybe the object is at 25 degree Celsius, then it is at 30 degree Celsius. That means the delta T will be what? 5 degree Celsius. So say for 5 degree Celsius the heat required is Q. So for 1 degree Celsius the heat required is Q by delta T. This will be here. Okay, that means for 1 degree Celsius the formula will be heat required and change in temperature. This is for whatever value we have. 1 degree इसके लिए कैसे निकालेंगे? Heat required divided by change in temperature. So this is what we are saying is this is heat capacity. So heat capacity will be given by, heat capacity is, it is denoted by capital C dash, that is heat required by unit change in temperature, or you can say not unit, change in temperature. How can we find out the SI unit of heat capacity? The SI unit for heat is joule. Change in temperature, that can be measured in Kelvin or it can be measured in degree Celsius. Both way it will be same. Why both way it will be same? Because the one when you are talking about 1 degree in degree Celsius, okay, when you are talking about 1 degree in degree Celsius, that will be same as 1 Kelvin. Means when you are talking about 14 to 15 degrees Celsius, the difference is delta T is 1 degree Celsius. When you are talking about 273 Kelvin to 274 Kelvin, delta T will be 1 Kelvin. This delta T, 1 degree Celsius, is equivalent to 1 Kelvin. So we can talk about, either we can write Kelvin here or we can write degree Celsius here. Both ways it will be correct. So SI unit will be joule Kelvin inverse, or this is joule degree Celsius inverse. That will be the SI unit for heat capacity. I hope you can remember this. Now we are going to study specific heat capacity. Now first question is, why are we going to study about specific heat capacity? When we are talking about heat capacity, beta, if you have observed, I believe you have clearly observed that we are talking about a specific temperature. Means we are talking about specific change in temperature. Every time we are saying by increasing the temperature by 1 degree Celsius, by 1 Kelvin. But we are not specifying about the amount of substance. And what is harmful in this? What is bad in this? Nothing is bad, but this way we cannot talk about whether the substance is a conductor or insulator after getting the value of heat capacity. How we cannot get? Suppose I am talking about a piece of wood and I am talking about a piece of copper. Okay. You cannot tell by taking this heat capacity into consideration that wood is a good conductor or copper is a good conductor. Why so? Suppose, because I told you I have two pieces, one is of wood and another is of copper. But I have not specified you the size of these two. Okay, I keep on supplying the heat at the same rate to both the pieces. Okay, and I have to raise the temperature by 1 degree Celsius. Suppose initially this is at 20 degree Celsius and this is at 20 degree Celsius, तो मुझे इसको भी 21 degree Celsius लेकर आना है, and I have to bring this also at 20 degree Celsius. That means the change in temperature in 1 degree Celsius is. Okay, so this is a smaller piece of wood. Okay, maybe with a very less amount of heat, because the piece is very small, it is able to raise its temperature by 1 degree Celsius. Means I want to say is it is absorbing less heat as compared to this piece of copper. It is absorbing more heat because the piece is bigger one, and it also has to raise its temperature by 1 degree Celsius. Then this is a contradiction which I told you earlier. What I told you earlier, I told you that conductors, they are going to absorb less heat and able to show the rise in temperature. But here I am saying this conductor is absorbing more heat and insulator is absorbing less heat. Why so? Because the size of this insulator and conductor, these are not relevant, these are not similar. I am not talking about same size, I am not talking about same mass, right? So to specify that how much amount of heat is absorbed by a particular substance to raise its temperature by 1 degree Celsius, और उससे हमें कैसे पता चलेगा कि ये कंडक्टर है, ये इंसुलेटर है? So we need to specify the amount of the substance. And how are we specifying it? We are specifying it by taking unit mass of the substance in all the calculations. Now what will be the result? If I am talking about unit mass of wood and I am talking about the unit mass of copper, both are of same mass. This is of unit mass 1 gram, this is of unit mass 1 gram, 1 kg or 1 kg. Okay, and if now I will supply heat at the same rate to both the pieces, definitely this will show rise in temperature quickly as compared to this. And with the values, because this has low specific heat capacities. Why specific? Because mass is specified. Because this has low specific heat capacity, that's why it is considered as conductor. It has high specific heat capacity, means it can absorb more and more amount of heat to show the rise in temperature. That means it is a poor conductor, so it can be considered as insulator. So to bring this comparison into consideration, to justify the comparison, to read out the things, to get the characteristic properties of the substances, we are specifying the value, and then we are saying this heat capacity as specific heat capacity when we are specifying the mass of the substance, right? Now we are going to talk about better specific heat capacity. What it is? It is the amount of heat required by unit mass of substance, by unit mass of substance to raise its temperature by 1 degree Celsius or by 1 Kelvin. This is known as specific heat capacity. This is denoted by small c. So this specific heat capacity is given by amount of heat required by unit mass of substance to raise its temperature by 1 degree Celsius. This is heat required, this is mass of the substance, this is change in temperature. So from here, how can we get this Q, that is heat required, is given by mc delta T. This is one of the formula which you need to remember to calculate heat again and again when we are talking about calorimetry. Because in calorimetry what we are saying, when two bodies are placed in contact with each other, one is going to absorb the heat, one is going to lose the heat. Okay, this measurement we are doing in calorimetry. So calorimetry is what? It is the measurement of heat. It is the measurement of heat, and that heat required we are measuring with the help of this formula. Or when we are talking about heat capacity, in that situation I told you heat capacity is given by Q upon delta T. So in this situation this heat required can be measured by C dash delta T, right? This heat capacity and specific heat capacity, these two are related to each other. How these two are related to each other, let's do that also. Consider these two equations. This is equation number 1 and this is equation number 2. This Q, that is heat required, is equal to this, and in this way heat required is given by this. Okay, so if these two are representing heat required, then we can substitute this value of Q over here. Okay, and what can we get? We can get C dash delta T is equal to mc delta T. Okay, this will be cancelled out. That means heat capacity will be mass into specific heat capacity. This is one of the relation which can also be used to calculate the heat required, or you can, which is also used to calculate the heat capacity, or used to calculate the specific heat capacity, or it is used to calculate the mass which is absorbing a particular amount of heat to raise its temperature. So all these are the relation which you need to remember for your numerical purpose. Q is equal to mc delta T, where m is the mass, C is the specific heat capacity, delta T is the change in temperature. Q is equal to C dash delta T. Q is the heat required, C dash is the heat capacity, delta T is the change in temperature, and heat capacity is equal to mass into specific heat capacity. Okay, now coming on to beta G, the differences between, or before that we can go for the SI unit of specific heat capacity too. Specific heat capacity we have written as Q is equal to, specific heat capacity C is equal to Q upon m into delta T. This Q is heat required, that is written in joule, mass that is written in kilograms in SI unit, delta T that is written in Kelvin. So this will be given by joule, kilogram inverse, Kelvin inverse, or as I told you we can replace Kelvin with degree Celsius also, so it can also be given by joule, kg inverse, degree Celsius inverse. These two are used as SI unit of specific heat capacity. Okay, now two questions we are going to do. These are important questions from your paper point of view. Suppose a statement is given to you, and according to that statement they are saying heat capacity of a substance, heat capacity of a substance is 40 joule Kelvin inverse, and they are saying what is the meaning of this statement. So how can you write it, beta? How can you tell the meaning of this statement? As I keep on telling you always, first when somebody is going to ask these type of questions from you, first of all write down this in the form of formula. How can you write it? This is 40 joules, and this Kelvin inverse you can write here 1 Kelvin. Now you can easily write it down. What is the meaning of this statement? This is what? This is Q. This is what? This is change in temperature. Q is what? This is heat required. Okay. This is what? This is change in temperature. Change means we are talking about rise in temperature over here. So you can write here this is rise in temperature. So how can you write here? Heat capacity of a substance. Substance ki jagah they can give you the name. Suppose they have given you the heat capacity of iron is this. So what can you interpret from here? You can interpret that 40 joules is the heat required to rise the temperature by 1 Kelvin. And for what we are talking about? We are talking about iron. Okay, so here what can we say? This is suppose iron vessel. So for this iron vessel, 40 joule is the amount of heat required to raise its temperature by 1 Kelvin. This way you can write it down कि ये जो भी आपको दिया है, ये आयरन का वेसल दिया है, ये आयरन का आपको कंटेनर दिया है, whatever they are writing here, this iron vessel needs 40 joules of heat energy to raise its temperature by 1 Kelvin. The mass of this is not given, initial temperature is not given, but you can tell that this is the amount of heat energy required to raise its temperature by 1 degree, चाहे पहले कुछ भी दिया है, that is just to rise in temperature. So whatever is the rise given over here, 1. Okay, similar way they can give you this statement in this form, iron, and they can write it here as 40 kilogram inverse Kelvin inverse. Now what is the meaning of statement now? Now you can write it here as 1 kg into 1 Kelvin. Instead of this you can write here, and here you can add mass. This is what mass of iron, because here iron is given to you. Now how can you interpret this statement? This specific heat capacity, you can write it here. This is specific heat capacity. Now you can say 40 joules of heat energy is required by 1 kg of iron to raise its temperature by 1 Kelvin. Whatever is given to you here, वही बस आपको लिखना है in terms में. अब आपको यहाँ क्या दिया हुआ है? 40 joules of heat energy is required. ये heat energy है. So 40 joule of heat energy is required for what? To raise the temperature by 1 Kelvin of what? Of 1 kg of iron. So these are the simple questions which can be asked in your exam. So please do practice for these kind of questions. Quickly we can go for the differences between heat capacity and specific heat capacity now. Now we are going to talk about better the differences between heat capacity and specific heat capacity. The first one is their definitions. Heat capacity is the amount of heat required to raise the temperature of substance by 1 Kelvin. No substance is specified, amount is not specified. In this specific, that means amount of substance is specified, amount of heat required to raise the temperature of unit mass of substance by 1 Kelvin. The formula for this is C dash, that is heat capacity is equal to Q, heat required upon change in temperature. This is specific heat capacity, small c is equal to heat required mass, mass into delta T, that is change in temperature. SI unit for this is Joule Kelvin inverse. For specific heat capacity is Joule kg inverse Kelvin inverse. This heat capacity depends on the mass, because no mass is specified over here, mass and material of substance, but in this case mass is already specified. This is of unit mass. Okay, so it is independent on the mass but depends on the material of the substance. And from the specific heat capacity, as I told you, this is the characteristic property of the substance, because we specified the mass. So how can we find out, how can we read it? We can find out that for conductors the specific heat capacity is low. The specific heat capacity is low because conductors are going to absorb less amount of heat to raise its temperature, and for insulators the specific heat capacity is high. The specific heat capacity is high because they are going to absorb more amount of heat to raise its temperature. So heat required to raise the temperature in case of insulators is high, and heat required in case of conductors is very less to raise its temperature. So I hope till here you can do all the topics. So please do one thing, read all the related content from the book till these topics and try to do all the questions from your exercises related to these topics. Rest of the topics we are going to discuss in next video. Bye bye and take care.